Welcome to the Hypervelocity Impacts in DESTI Plasma Lab. The HIDPL comprises the experimental arm of CASPER and operates equipment allowing investigation of complex or dusty plasma. Dusty plasma is plasma with millimeter to nanometer dust grains embedded in it. Depending on the plasma parameter space and the size of the dust grains, multiple research areas can be examined employing the research equipment within the HIDPL. At the millimeter size range, dust particles act as dust in plasma, which provides a window into astrophysics, space physics, marine system physics, and protoplanetary physics. Moving to the micron size produces a system where dust may now be considered an actual component of the plasma, giving rise to entirely new physics, such as dust particle crystals, which can be transitioned from a solid to liquid to gaseous phase in a controlled fashion, and additional plasma wave structures that only exist within dusty plasma, for example, the dust density waves or the dust acoustic waves. This is why dusty plasma is now considered the plasma state of soft matter. Reducing the size of the dust particle again into the submicron regime allows the particles to act as non-perturbative probes of the plasma, providing the ability to examine properties of the plasma that are difficult or even impossible to measure using more normative techniques such as Langmuir probes. Finally, moving into the nanometer regime provides coupled dust plasma systems which can act as analogs for semi-classical or even quantum systems, opening the door to the exploration of a parameter space heretofore not accessible to physicists. As you might suspect, all of the above require specialized equipment to examine experimentally. The HIDPL has two GEC RF reference cells that allow controlled experiments across a large parameter space and offer a highly developed set of diagnostics to cover these experiments. The first of these was actually the third in the world when it was built, and has recently been reworked to provide an even larger operating space under even more highly controlled conditions. We also have a third RF cell that was built specifically to examine large dusty plasma systems. In fact, it can have up to a 26-inch lower electrode, allowing investigation into large system development and the examination of long-range forces. This cell is one of two in the world, with the other being run at the DLR in Germany by a CASPER member on staff there. This international collaboration gives us the ability to compare data and conduct experiments that neither lab would be able to conduct alone. The newest cell in the lab is a DC cell and was built specifically to act as an analog for the Plasma Crystal 4 device currently on the International Space Station. The PK4BU device is the only one of its kind in the world and provides the opportunity to explore experimental ideas before they are actually proposed for the PK4 on the ISS. Even more importantly, it also allows exploration of system parameters that are unavailable on the ISS. It was built as part of an international collaboration between CASPER, the DLR in Germany, Roscosmos in Russia, the Wigner Institute of the National Academies of Hungary, and is routinely used by faculty from Auburn, Wittenberg, University of California, San Diego, and from other scientists around the world. Yet another international collaboration between CASPER is the relationship between CASPER and the IRS at the University of Stuttgart. This led to the development of the IPG, or the inductive plasma generator. This device operates at much higher powers than do the RF reference cells and provides the ability to examine plasmas germane to electric space propulsion efforts, reentry shielding of spacecraft, and soon dusty plasmas and strongly flowing ion systems. The collaboration between CASPER and the IRS has also resulted in doctoral and master's students from Germany spending extended periods of time at CASPER conducting their research. Finally, the HIDPL is true to the long-range history of this SSL and of the HIDPL and is active in CubeSat research. CubeSats are small satellites that can be produced by students at a university level but provide data rivaling that of Grand Challenge devices such as the Hubble Space Telescope. CASPER currently has a CubeSat with the Air Force awaiting insertion into orbit and another campaign under discussion. All of the above would obviously not be possible without our sponsors. The HIDPL is currently funded by NASA, the NSF, and the DOE, as well as others, and is grateful for this funding.